Let's find the derivative of a square root expression using the limit definition. So suppose that f of x is equal to the square root of x plus 2, and I want to find f prime of x. The limit definition says that f prime of x is equal to the limit as h goes to 0 of the difference quotient, which is f of x plus h minus f of x all over h. So I'm letting h go to 0. I'm letting these points get closer and closer. I'm trying to find that instantaneous slope. To do this, I need f of x, but that's my starting function. That's the square root of x plus 2. And I need f of x plus h, which is that same function, but instead of x, I have x plus h. So plugging those in gives me square root of x plus h plus 2 minus the square root of x plus 2 all over h. And right now, if you were to plug in 0 on the top, you would have the square root of x plus 2 minus the square root of x plus 2 all over h. This goes to a form of 0 over 0. So I'm kind of stuck. But one thing I can do with square roots is I can always multiply the top and bottom by the conjugate. The conjugate is going to be that same expression, square root of x plus h plus 2. That's square root of x plus 2. But you're going to change the center sign so you end up with a difference of squares. You have the plus and the minus getting multiplied together. I'm going to leave the denominator alone because it's looking pretty messy there. I have h times the square root of x plus h plus 2 plus the square root of x plus 2. If I multiply out the top and I FOIL, these first two square roots are going to cancel and leave me with x plus h plus 2. I'm going to have a plus and a minus of the same thing. That's going to cancel out. So the only other piece I have, the O and the I of the FOIL have canceled, is the L, the last. If I multiply the square root of x plus 2 times x plus 2, that gives me x plus 2 with no square root. The square roots have canceled. So multiplying by conjugates, it does make it look messier, but it gets rid of some of those problematic square roots on the numerator of my fraction. Because if I were to plug in 0 into the bottom here, I would have x plus 2 plus x plus 2. Those wouldn't cancel out. Those would just stay there. Let's see if I can simplify this a little bit more, though. I have the x's are canceling. I have the 2's are canceling. So the only thing left on the numerator is h. But I have an h in the denominator as well. So if I think of this as h plus 1, or sorry, h times 1, and I divide the top and bottom by h, that leaves that placeholder 1 still in the numerator. And in the denominator, I've got the limit as h goes to 0 of 1 over the square root of x plus h plus 2 and the square root of x plus 2. There's only one h for me to plug that 0 into. Let's go ahead and do that. That leaves me with 1 over the square root of x plus 0 plus 2 plus the square root of x plus 2. Technically, I'm done, but let's make this thing look nicer. I have 1 over 0 plus 2 is 2, so that's the square root of x plus 2. And that's the square root of x plus 2. I have 2 of those things, so combining them together, I have 1 over 2 square root x plus 2 as my derivative. So my derivative function for this square root is 1 over 2 square root x plus 2. When you're working with square roots, again, a really good strategy is to multiply the numerator and the denominator by the conjugate. That's the same thing with the opposite sign. When you do this, it gets worse first because you have more things, but a lot of stuff will cancel out, and it usually allows you to simplify into a much nicer expression by the time you get to the end. So that's what we got going on here for this problem. Let's check out some more problems together.